ghetto, but this is the best I could do. Alright, so the question is, I have 100 milliliters that contains all this, and it wants to know what will the pH be after I add 10 milliliters of this concentration of hydrochloric acid. So since this is a buffer solution, and I know that because I have my weak acid and the conjugate base, I'm trying to find the resulting pH after I've added a strong acid to a buffer. So in order to do that, first thing I need to do is figure out what the pKa is. So I'm going to use the equation eventually. pH, the Henderson-Hasselbalch equation, is equal to the pKa plus the log of A minus over HA. So my goal is, they gave us the Ka, so I need to get the pK from that, and then I need to find out after everything is done, what is the final concentration of conjugate base and what is the concentration of the undissociated acid. Okay, so as far as the pK, that's pretty straightforward. They tell us in the problem that the pK, or the Ka, is equal to 1.8 times 10 to the negative 4. So to get the pK, I take the negative log of the Ka, which is going to give me 3.74. Okay, so now I need to find the number of moles of everything I have in this solution. So I'm going to need to know the moles of fluoride, the moles of hydrofluoric acid, and then the moles of hydrochloric acid that are being added. So to do that, I'm just going to do 0.100 mole per liter. That's the concentration of the fluoride ions times the volume, which is 0.100 liters, and that tells me that I have 0.01 mole fluoride. I'm going to do the same thing with the concentration of hydrofluoric acid in the beginning, which is 0.126 moles per liter times 0.1 liters, which gives me 0.0126 mole hydrofluoric acid. And then when I add my 0.100 mole per liter hydrochloric acid, and it's 10 milliliters this time, so 0.01 liters that are being added, that's 0.001 mole of hydrochloric acid. Ignore the technology that I'm using. Okay, so now I need to do an ice table where I look at the reaction of the, in this case, the fluoride ion is going to be acting as a base. So what I have is, sorry, trying to figure out the best way to write this. What I'm going to have, I swear I wrote this out already. Okay, I'll just redo it. What I'm going to have is my fluoride is acting as a base, and it's going to be reacting with the hydrochloric acid to form hydrofluoric acid and the chloride and then water. And both of these don't really matter. So what I really care about is the fluoride, the hydrochloric acid, and the hydrofluoric acid. And remember, the fluoride is going to act as a base by picking up this hydrogen, generating the chloride and the hydrofluoric acid. So in the beginning, the moles of fluoride are just the moles that I put in, which are 0.01, because I just calculated that. The hydrochloric acid is going to be the moles that I'm adding, which is 0.001. That's how much I'm adding. The hydrofluoric acid is 0.0126, and then I'm not worrying about this other stuff because it doesn't affect the pH. Since hydrochloric acid is going to dissociate completely because it's a strong acid, and since the whole point of the buffer is that it's going to neutralize whatever I'm adding, all of this, remember you described it as being the limiting reactant, is going to be used up. So 0.001 of this is going to disappear. So this is going to go down by 0.001. So if this is going down by 0.001, that means this must be going up by 0.00. Sorry. This must also be going down by 0.001 because it's reacting with that 0.001 of this. So that's also minus 0.001. and this is going to go up by 0.001 because that's what it's forming. Okay, so now I'm going to figure out these numbers. So 0.01 minus 0.001 is 0.009. This is going to be 0, and this is going to be 0.011. So the numbers that are important here are this, because that's my HF, and this, which is my F minus. So now I can go back to that Henderson-Hasselbalch equation, and I have my pH is equal to the pKa plus the log of A minus over HA. The pKa we calculated before somewhere. At least I thought we did. It's 3.74. 3.74 plus the log of A minus, which is 0.009. Right? F minus is A minus. That's the conjugate base divided by the undissociated acid, the HA, which in this case is HF, which is 0.011. And when I plug that in, I find out that my pH is equal to 3.65. Though I feel like that's not the right number of significant figures. I think I actually, because I can't remember if the 100 milliliters has a decimal point after it, so it may just be 3. I would have to go back and look at the problem to know how many sig figs, but that's your answer.